This video is a continuation of the time value of money concepts video. In this video, we're going to cover a mishmash of other time value of money concepts. The first concept we're going to cover is the increased frequency of compounding. Let's use an example. Let's say that we have $100 right now, and if we invest it at a 12% annual rate of return, we will have $112 1 year from now. And our effective interest rate is simply going to be the 112, or 12%, 112 divided by the 112, or the 100, excuse me. However, if we have monthly compounding rather than annual compounding, notice our beginning value is still 100. However, we start earning interest immediately, and after 1 month we're going to have $101. In time period 2, or in the second month, we're going to earn another 1%, but now we're already earning interest on interest, so we're going to earn an extra penny on this $1 that we previously earned. At the end of time period 3, we're going to be up to $103. And if we keep working this way, at the end of 1 year or 12 months, we will have $112.68. And so therefore, our effective interest rate is 12.68% rather than the 12% identified earlier. So the idea is the more frequent the compounding or discounting, the higher the effective rate of interest. The next concept that we're going to tackle is the calculation of a future value. Let's do a simple example here. Let's say that we want to invest $5,000 today at a rate of 7%. How much will we have 10 years from now? Well, we have $5,000, and in this case we'll just use annual compounding, so 1 period per year. Our annual percentage rate is going to be 7%, or 0.07. Total number of years is going to be 10 years. And so our total payments is going to be equal to the 10 years multiplied by the payments per year. And so we have a total of 10 periods. Our periodic interest rate is going to be equal to the 7% divided by the 1 period per year. So our periodic rate remains the same as our annual percentage rate, or the quoted rate. So now the calculation is an FV function, or is a time value of money function. If we go up here into the insert function and type in FV and hit return 2 times, our interest rate is going to be equal to the periodic interest rate. Our number of periods is going to be equal to the total number of periods. And so our present value is the $5,000. So $5,000 invested for 10 years at 7% is going to be equal to $9,835.76. So at this point, we can say, but what if we have monthly compounding rather than annual compounding? Well, in this case, all we need to do is change the number of periods per year to 12 rather than 1. And notice that we have a slightly higher future value because we start earning interest on interest more frequently. The next item that we're going to cover here is the opposite of finding a future value. It is finding a present value. Let's take a look. Our question is, what is the present value of $10,000 10 years from now discounted at a rate of 7%? So we have the same kind of setup. The number of periods per year is 1. The annual percentage rate, or the quoted rate, is 7%. Number of years, 10 years. So the total number of periods is going to be equal to the 10 years multiplied by 1 period per year. The periodic interest rate is going to be equal to the total quoted rate multiplied by the periods per year. not multiplied, divided by the periods per year. In this case, the future value is $10,000. Now, the calculation of the present value is a time value of money function. If we click on the Insert Function button, let's go ahead and type in PV and hit Enter 2 times. Our rate is going to be equal to the periodic interest rate. Our number of periods is going to be equal to the total number of periods, which is equal to 10. And so therefore, the future value is $10,000 10 years from now. And hit Enter. So the equivalent of $10,000 10 years from now, discounted at a rate of 7%, is equal to $583.49. The opposite of that, it's like saying $5,083 invested today for 10 years at 7% is equal to $10,000 in the future. So finding a present value is exactly the opposite of finding a future value. And the inverse of that is true as well. Now then, we can say, gosh, what if we had monthly compounding rather than annual compounding? So in this case, the total number of periods, the periods per year, if we change that from 1 period per year to 12 periods per year, now you notice that it's a little bit less, okay? That concludes this video. We will continue on with the next video in dealing with annuities and graduated annuities.